David Smith here with one more flipped classroom math video. 3 tips before we start. First, you could speed up the playback and get through the video a little quicker, as long as you can still understand. Second, you can pause the video at any point to catch up with your notes. And third, you can turn on the captions and watch my words go by on the bottom of your screen.
Today's lesson covers a calculation we call the inverse normal. Now, let me explain how that works. First off, just remember that almost every single mathematical operation has an inverse. So like if you take a number, multiply it by 7, and then divide it by 7, you're back where you started from. So division is the inverse of multiplication, and so on. So the inverse normal calculation just goes backwards. And so here's how we use that. Here's my normal distribution and my values here. And then here is my probability that an outcome will fall within these values. So here's what we say. We're going to find A and B if the probability is known. So in the past, what we've done is I've given you values of A and B and asked you to calculate the probability of an outcome falling within that range. Now what we're going to do is we're going to give you the probability and ask you to find A and B. Let's do a problem. So check this one out. Cauliflower weights. So in other words, we're maybe in a giant supermarket and we're weighing all the cauliflower that's coming in, or maybe we're in the production facility. That's a little better. So we're trying to grade our cauliflower by weight, because maybe we're going to sell some differently if they're really big or if they're really small. So check this out. Cauliflower weights are normally distributed. So this tells you we can use all of our normal distribution tools to analyze the situation. With a mean of 821 grams and a standard deviation of 40 grams. First prompt, sketch or draw the distribution. Okay, so check this out. Here's my bell-shaped curve. A pro tip here is what I did is I drew my curve first, because then I can focus on making it symmetrical, and then I went ahead and put my x-axis and my y-axis on it. So if you're having trouble making your curves look nice, go ahead and try that trick and see what happens. Okay, so then what I did is I labeled my mean, and then I labeled 1 and 2 standard deviations away from the mean. So I'm just subtracting 40 going that way, adding 40 going that way. All right, before we move on to our next prompt, I just want to remind you of some features of the standard normal distribution. So check this one out. We have 68.3% of our data is between 781 and 861. In other words, 68.3% of the data is within 1 standard deviation of the mean. Similarly, 95.5% of the data is within 2 standard deviations of the mean. So 95.5% of the data is going to fall between 741 and 901. So this is the territory that we're in, and we're going to use that to evaluate the next prompt. All right, our second prompt. The lightest 8% are considered undersized. So we're packaging it up for sale in a supermarket, but 8% of those, the smallest size, they're just a little too small. We need to do something else with them. So what I want you to do is add this information to the diagram with some shading. So in other words, shade the area that's considered undersized. Okay, so check this out. It has to be between 741 and 781. If you're thinking about the tail that's going off this side, remember the tails beyond 1 standard deviation are about 32%. So this one's going to be half of that. So the whole distance from 1 standard deviation is maybe 16%. Similarly, the tail from 2 standard deviations away is going to be like 2-something%. So it's going to be somewhere in between. So I just went ahead and marked my A. Remember, that's what we're doing with these. We're finding these values. And then I shaded the area, and then I marked it as 0.08. Remember, 8% is 0.08. Remember, the whole area under the curve is 100% or 1. So this is going to be 0.08 for 8%. Okay, here is our prompt. Find the weight. So in other words, what is the weight below which we have undersized cauliflower? So I want to write this in our probability notation. Okay, so actually pause the video, see what you can come up with here. Okay, check this out. I added 2 lines of notation to help us articulate this problem. Here's the territory. X, I'm using X for a random variable. I guess we could use C for cauliflower. Anyway, X is part of a normal distribution with a mean of 821 with a variance of 40 squared. Remember, the variance is the standard deviation squared. So we know that the probability of X being less than A is 0.8. Now, in the past, you've been given problems where we tell you what this value is, and you're using your calculator to find the probability. So now we're doing it in a backwards way. So in the video, there's a link below. I want you to pause the video, take a look at that video real quick. It's also on YouTube. See how to do the standard inverse normal distribution calculation, and then do that with what you know here and come back. All right, here we are. The A value in here is 765 grams. So that is the dividing line. That's the weight below which cauliflower are considered underweight. So I just went ahead and wrote that in a sentence. Now that you're familiar with that and you understand what's going on, I'm now going to give you another prompt. Okay, here's a different prompt. If the heaviest 8% are considered jumbo-sized, find that weight. There's 2 ways to do this, one with your calculator, one with pretty much just your brain. So go ahead, think about that. See if you can do it 2 ways, and then come back. Okay, so here's what we're looking for. We're finding the probability that X is greater than B. Actually, we know that probability, that's 0.08. We want to find what B is. So before we get to that, I went ahead and shaded that on my diagram on this side. So here's my B, don't know yet. It's somewhere between 1 and 2 standard deviations from the mean. And I shaded it and I labeled it with the probability that we know. Then I went ahead and put this into my calculator and I get 877. Now, that's a straight up way to do it, and you can do that all day long and you'll get full points for your work. However, there's a nice quick way to do that involves understanding something about our normal probability distribution. So if you haven't already figured that out, pause the video, think real hard, come back. All right, the key thing here is to remember that the normal distribution is symmetrical around the mean, so we can exploit that. The distance in weights below the mean that get us to this 8% boundary, where these are all undersized, is the same as the distance from the mean to the upper boundary, because we're saying 0.08% on both sides. So these areas are the same. It means that these A and B have to be the same distance from the mean. So I found that distance here by subtracting that lower boundary from 821. That gave me 56. So I went ahead and added 56 to the mean again, and I got 877. That's the same result that comes out of your calculator.
Now that you've watched the video, take a moment to write down any remaining questions so you can be sure you ask them in our next class. You can also watch the video again if you need to deepen your understanding. And if you enjoyed the video, please click like.